Hello everyone, in today's class we're going to look at how we measure pressure, what instruments we use, and how do they work. So for example, one of the basic ways of measuring pressure in the old ways was a piezometric tube, which is basically a tube that has a fluid inside. Okay, and what they do is they open a small opening in that tube. And usually when you break a hole through a tube that has fluid in it, what would end up happening is the fluid inside will come out in a very high pressure. Now, what the piezometric tube does, it has a clear tube that allows the fluid to be contained in instead of going to waste. And what ends up happening is the fluid would go to a certain height and then settle. It won't go down. It won't go to infinity. It will reach a certain height based on its pressure and settle there. Now, if you measure the height from the center line to the level of that fluid, that will give you the height used to find the pressure of the fluid inside the tube. Okay, so if we have a specific weight of the liquid and we want to find the pressure of the center line, how would we go about it is the pressure at the center line minus gamma H, and the reason why it's minus is because pressure is going upwards. When pressure goes up, it's minus, and when pressure goes down, it increases. It's plus. Okay? Equal to 0. And the reason it's 0, it's because the fluid is open to atmospheric pressure. Okay? Therefore, P equals gamma times H. And that's how you find pressure in a piezometric tube. Piezometric tube, or it's called piezometer. Okay, now the only problem with a piezometer or a piezometric tube is that it's not as efficient for light fluids. And the reason behind that is light fluids have a very small specific weight. What would end up happening is, for example, if you have water in this tube, what would end up happening is that the fluid would go up a higher distance. For example, if we say the pressure inside this tube is 1 atm, in order to read the pressure for this tube using a piezometric, you need to go up 34 feet just to read the pressure. And for example, if it's 2 atm, you would need to go up 68 feet, and you need to go up like 7-8 stories in order just to read the reading. So there has to be a better way to read the pressure, and that's where the U-tube manometer was invented. Manometer was invented. It's the same idea with small differences. It's, for example, if you have a tube of fluid, let's say it's a pipe. Okay, gamma 1, this is your center line, and you want to find the pressure at the center of that tube. What you'll do is, it's a little similar to the piezometer, is you'll have an opening in that tube, and you'll attach a manometer, U-tube manometer to it. Okay, let me redo this. looks something like that. Okay. Let me just erase this. Bring it down a little. Okay. Now, the only difference is that you'll add a heavier fluid. If we call this gamma 1, we'll call this gamma 2. And that heavier fluid, and the reason why you'll add a heavier fluid is because you don't want it to go as far. You don't want the delta H to be very high. So usually you'll use mercury, which is heavier than water. Therefore, the distance it travels based on the pressure won't be that high. So one of its requirement is that gamma 2 needs to be bigger than gamma 1. Okay. Now, the height from the center line to the new fluid, that is your H1. And since horizontal planes, the pressure does not change in horizontal planes, the pressure at this point and this point is the same. Therefore, this will be your H2 or delta H. Okay, that will be your H2 and this is your H1. Now, to find the pressure at the center line, what you'll do is PC minus, no, actually plus, because the pressure, the liquid is going downwards, and when you go downwards, pressure increases. So plus H1 gamma 1, which is this liquid here. Okay? Minus, because pressure is going up here, it's going upwards, we're assuming this, the pressure at this point is equal to the pressure at that point. So we're going to start the H2 measurement from this point upwards. And by the way, the manometer is open to atmospheric pressure, so we'll equal it to 0 gauge. Okay, so minus H2 gamma 2 equals 0 gauge. We went through this in a couple of classes back, which basically means that, hey, this is atmospheric pressure, but in gauge, it's 0 gauge. Okay, we went through the difference. Now, solving for PC, the pressure at the center line, PC equals H2 gamma 2 minus H1 gamma 1. And that is the U-tube manometer. It's the same idea as the piezometer. The only difference is we're using a heavier fluid to measure the pressure. And as I discussed before, heavier fluids, you don't need to travel, you don't need to go as high as a lighter fluid to read the level. So just to clarify, 1 atmospheric pressure is equivalent to 101.3 kPa, is equal to 101.3 kPa. It's also equal to 14.7 psi. It's just different units. It's equal to 760 millimeters of mercury. It's equal to 30 inches of mercury, and it equals to 34 feet of water. So you can see here the difference between a heavier fluid, mercury, and a lighter fluid, water. And air has a even lighter specific gravity. But for 1 atmosphere, you need to go up 34 feet just to read the water pressure, which is about for 5-6 stories or levels, just to read the pressure, whereas for mercury, it's much, much, much smaller. It's only 30 inches of mercury. So that's the reason why you use a heavier fluid in a manometer to read the pressure. The specific weight, gamma 2 needs to be bigger than gamma 1. That's it for this class. See you in the next one.